In this problem, we need to show that the second derivative of y with respect to x is given by this particular expression, provided y is equals to tangent of x plus secant of x. So let's begin with whatever we are provided with. We have y equals to tangent of x plus secant of x. Right. We'll take the derivative of both sides of equation number 1 with respect to x. That gives us dy over dx, which is equals to derivative of the tangent function as secant squared x plus derivative of the secant function as secant of x times tangent of x. So let this be equation number 2. Now we'll again take the derivative of 2 with respect to x, and that gives us the second derivative of y with respect to x equals to derivative of secant squared x. So secant squared x can be obtained by, let's write it down. We have derivative with respect to x of secant of x whole square. The reason why we're writing secant of x whole square, so that we can apply the power rule here, plus derivative with respect to x of secant of x times tangent of x. And here we can find out the derivative by applying the product rule. So let's obtain the value. So this will be equals to 2 times secant of x raised to the power of 2 minus 1 multiplied to derivative with respect to x of secant of x. So here we have applied the chain rule here. Plus, we'll consider secant of x as the first function and tangent of x as the second function. So we have derivative with respect to x of the first function, which is secant of x, multiplied to the second function, plus the first function, which is secant of x, multiplied to derivative with respect to x of our second function, that is tangent of x. This will be equals to 2 times secant of x, derivative of the secant function, so that's secant of x multiplied to tangent of x, plus derivative of the secant function, so you have secant of x times tangent of x multiplied to tangent of x plus secant of x times derivative of the tangent function is secant squared x. Fine. Now let's multiply them. So we have second derivative of y with respect to x, that's equals to 2 times secant squared x times tangent of x plus secant of x times tangent squared x, plus we have secant of x times secant squared x, so that becomes secant cube x. Now, in our problem, we can see that the second derivative of y with respect to x is given in terms of cosine and sine. What we'll do, we'll combine all the secant and tangent to the respective sines and cosines. So let's do that. So this will be equals to 2 times, so we have secant squared x, so secant squared x will be reciprocal of the cosine squared function. We have cosine squared x in the denominator multiplied to tangent of x, or tangent of x will be sine of x times divided by cosine of x, plus 1 over cosine of x times, so tangent squared will give us sine squared x divided by cosine squared x, plus secant cube squared x, so that will become 1 over cosine cube x. So we will combine the denominator. The denominator will be cosine cubed x. So that means we have 2 times sine x plus sine squared x plus 1. Now 2 times sine x plus sine squared x plus 1, this is actually 1 plus sine x whole squared. So if we expand it, we'll get the numerator divided by, we have cosine cubed x, so we can rewrite it as cosine of x times cosine squared x. Right. So that will give us 1 plus sine x whole squared divided by cosine of x. So in place of cosine squared x, we can rewrite it as, so let's do it here. So we have cosine squared x, so this is actually equals to 1 minus sine squared x. Here we've used the fact that the cosine squared x plus sine squared x is always equals to 1. It's an identity. So that means 1 minus sine squared x can be also expressed as the product of 1 minus sine x and 1 plus sine x. So let's use this. We'll have cosine of x multiplied to 1 minus sine x times 1 plus sine x. Right. So that means this is going, we can cancel out 1 plus sine x from both the numerator and the denominator. So that gives us 1 plus sine x divided by cosine of x multiplied to 1 minus sine x. Now what we'll do in the next step, we will multiply both the numerator and the denominator with cosine of x. So that means in the denominator we'll get cosine squared x. Again, we'll use this. So this will give us cosine of x multiplied to 1 plus sine x divided by, since we have cosine squared x, so we will use it as 1 plus sine x multiplied to 1 minus sine x, and we already have 1 minus sine x, right? So here 1 plus sine x will get cancelled out, and finally this gives us second derivative of y with respect to x. So this will be equals to cosine of x divided by 1 minus sine of x whole square. So this is what we were asked to prove.